Hello, welcome to the video on sequences and patterns. This will be a lesson on this topic, and let me just say right up front that what we're going to be talking about, a lot of you may have studied before, maybe at a little bit more advanced levels. So we're not going to be covering all the things that you may have seen when it comes to sequences and a related topic called series. So this is a kind of an introductory level type of video, but we're going to be covering a good amount. So if you're not familiar with sequences and some of the things we're talking about, this would be an excellent start for your education. If you've seen some of these things before, again, we're not going to be covering all the details of what you will very likely be learning in the future, okay, in terms of you continue on with your math education. All right, so let's go ahead and take a look at our objectives for this lesson. So first, we're going to go ahead and define a sequence, and then we're going to define and explore arithmetic and geometric sequences, and then we're going to learn how to look for patterns in numeric and non-numeric sequences. Okay, so before we get started, as usual, make sure you're taking good notes, pause the video as necessary, and let's go ahead and get started. Okay, so sequences, what are they? Well, you probably have heard this word. Okay, it's a common word that we use in our vocabulary. So before I get into everything that's here, we can say, what's the sequence of, let's say, a parade, right? So the parade, you might have a car come out, let's say it's the mayor, then the next thing might be a band, and then the next thing might be a float, etc. So there's some sort of specific order, right? So there's things are lined up, and it's a very kind of special order or specific order of events, okay, or these objects, okay, are in a particular order, and that's what a sequence is, okay. So a sequence is a list of numbers or objects in a special order. Now, because this is mathematics, we're mostly going to be focusing in on numbers. So here is an example of a mathematical sequence. So we have some numbers here, okay, and the commas indicate that this is something, and then we're putting these numbers in a particular order. So we're separating them by commas. So this is the way a sequence looks like. So if you have numbers separated by commas and you have like a dot, 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 that just means that the pattern continues on, okay? So this continues on. It's kind of like having a parade. If I have dot, 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 that means there's more things that are coming down, behind the float. This parade there's more things way behind this vehicle, for example, okay? So this is what a sequence would look like. And you can see here, these numbers are obviously in some sort of special order, right? But we're going to talk about that here in a second. But before we do that, let's get some basic terminology down. So again, these numbers, they're separated by commas, and when we're indicating this is some sort of sequence, some sort of pattern of numbers, and the things that are in the sequence, the individual kind of elements of them, are called terms, okay? So you want to know that language, terms, and we describe these terms by their place, their order in the sequence. So this first number is called the first term. This second one is the second term, etc., right? So the terms continue on. Now, in more advanced math, you may have seen something like this, a sub 1. This is the first term. A sub 2. This is the second term. Then way out here is a sub n. This could be any term. So if you're seeing this notation before, if you're like, yeah, I remember this, maybe in your high school mathematics and algebra 2 or whatever level of math that you may have taken, and that's exactly what this is going on. But we don't need to get into this more advanced notation. I bring it up just in case if you have seen it, but we don't have to describe a term. We can just call this the first term, the second term, etc. As long as you understand it, it's whatever value is in that particular place in the sequence. Now, another thing I want to talk about real quick is this idea of series. Now, the concept of series is not going to be taught formally in this lesson, okay? But I want to just give you a basic idea of what a series is. So a series is the sum of the terms of a sequence. So basically the way it would work is saying, okay, a series would say take this sequence and add up the first to the fifth term. So that means add up 2, 4, 6, 8, 10. So 2 plus 4 plus 6 plus 8 plus 10. This right here would be an illustration of a series. So a series is where you add up the terms, a finite amount. Well, it could be even an infinite amount, but basically it's adding up the terms or some of the terms of a sequence. That is a series. So just in case you run into a question about series, that's what it is. All right, so let's continue on. So when we have a sequence, we want to kind of study the pattern between the terms to find the value of the specific term. So for example, here, I got to study what's going on between 2 and 4. So how do we get from 2 to 4? Well, we can either have multiplied by 2 or we can add by 2, right? That's how we went from 2 to 4. But you're saying, okay, if it was multiplication by 2, you have to see if it works for the next pair of terms here. So 4 and 6. Now, if I multiply 4 by 2, I get 8. So that's not working. So the rule here is I'm adding by 2, right? So 2, just keep adding to 2, keep adding to 2, keep adding to 2. So if I wanted to find the 7th term, well, I'm not going to be able to answer that question until I get the 6th term. So I have to go back to this 5th term, add 2 to it, I get 12. And then now that I have the term previous to the one I'm looking for, I can just add 2 to it and get 14. So this is kind of what you're going to be doing in a lot of the exercises and questions, but this is how we handle sequences. Okay, we have to figure out first, what is the pattern? What's the rule? Okay, how is one term getting to the next term? We have to determine that, and then we can answer questions about, other terms in the sequence. Okay, so you can kind of see that right here. All right. Now let's go ahead and talk about two very, very important type of sequences. One is called arithmetic, and the next is called geometric. Very important. Okay. Now again, a lot of you have already studied this at maybe a bigger level, but this is kind of, again, an introductory level lesson. Okay. All right, so arithmetic sequence. So what is that? Well, basically it's a sequence where you add or subtract the same number to get to the next term. This right here is an arithmetic sequence because to get to the next term, we just add a 2. Okay, to get this from 4 to 6, we added 2. Get to 6 to 8, we added 2. So anytime you're adding or subtracting the same number, okay, it's called an arithmetic sequence. So let's take a look at 2 examples here. So you can see here from 1 to 5, I'm adding 4. 5 to 9, I'm adding 4. You have to check that if I told you this is not an arithmetic sequence, if I just said, hey, what type of sequence is this? You have to do more than just check the first 2. You have to check a couple, okay? Now I'm adding 4. This works. Okay, let me just go from here to here. That works as well. And you might want to just check one more, okay? So, all right, this is working. So what's going on here is you're adding the same number to get to the next term, all right? Now, that same number that we're adding or subtracting is called the common difference. You need to know this language, the common difference. So the common difference in an arithmetic sequence is that one number that you're adding or subtracting to get to the next term. Let's take a look at this sequence and see where the subtraction example would come in. So you can see from 20 to 17, what's going on? Well, it looks like we subtracted 3. Okay, well, does it work for the next pair of terms? If I subtract 3 from 17, do I get 14? Yes. 14 from, if I subtract 3 from 14, do I get to 11? Yes. So you got to check a few of these to make sure it is the same number. And then if you're adding or subtracting the same number, these numbers here would be called the common difference. Okay, let's talk about geometric sequence. Now, geometric sequence is very much like, at least conceptually, like arithmetic, an arithmetic sequence, but in this case, we're going to be multiplying the same number. So that same number is called the common ratio. So to get from one term to the next, we're going to be multiplying. So when you have a sequence where you're multiplying the same number as a geometric sequence, so you can see here from 1 to 3, I'm multiplied by 3, but we got to check. Okay, to go from 3 to 9, if I multiply by 3, does it work? Yes, it does. How about 9 to 27? If I take 9 and multiply by 3, do I get 27? Yes. So this same number, okay, instead of adding or subtracting, we're multiplying. That's a geometric sequence, and that same number is called the common ratio. Now, one thing about geometric sequence is this is an example of what we call exponential growth, or exponential, it's an exponential function, okay, in mathematics, or geometric growth. So you've probably heard that before, or compound growth. And that's the kind of growth where things kind of start off slow and then they really take off. This is an example of, like, so let's say population growth, or maybe in money investments over time. It grows, and you probably heard that if you save $100 every month, and over 30 years you'll have $2 million, whatever the case might be, a certain interest rate. It's like you keep adding, but then things start growing really large as you go out in time. This would be an example of how, let's say, bacteria grows, or how a virus spreads, something along those lines. Okay, so geometric growth, exponential growth. This is an example of a geometric sequence as well. Okay, all right, so just a word that you want to be familiar with, geometric, and what does it mean. Okay, so now let's talk about exploring patterns. And there's all types of different patterns out there, any infinite amount of type of things. And you know, our brain, the way we kind of look at things, we kind of interpret what's kind of going on. So let's take a look at that. We'll talk about some general principles on how to find a pattern. So here you can see, this is, you know, we're not talking about numbers here. We're talking about some sort of pattern that's occurring. And I can see, okay, the first thing I'm looking at is one triangle. Then the second thing I'm looking at is two triangles, but it's like this triangle is reversed, right? And kind of glued next to it. And then the third thing I'm looking at is there's three triangles here, and they're kind of alternating, they're kind of flipping next to one another. And here's the fourth. So you might want to say, what would be the fifth thing in this pattern? Okay, well, what we have to do, okay, when it comes to patterns, and you could probably already answer that question right now. You're probably, oh, okay, yeah, what looks like you would do is you would just draw this down and be like this, and this would be the next, this would be the fifth thing in that pattern. And you would be correct, but this is a pretty, I think, pretty easy pattern, but it's a good pattern for just us to start talking about how to find a pattern. Okay, so in general, one, like, what do you know? Okay, well, this is all I know. This is all the information I'm given. The next thing is you got to look at what repeats or changes. Okay, so the second thing in this pattern, there's two. The third thing is you have to study the pattern, right? But you want to be looking for what is repeating, what is changing, etc. Okay, you're looking for what's kind of going on. Okay, and then you're going to check if you think that you figured out what is repeating or changes. Then you're going to need to check what repeats or changes that works for all cases. So just like with our arithmetic or geometric sequences, you want to check with more than just two terms, right? You want to just, let's say, from here to here, you're like, okay, I know what's going on. Well, make sure it works for here to here and here to here, for example, right? Make sure it works for all cases that you have available. Then you want to kind of try to formally describe the pattern. So there's a lot of ways to do this, but that's kind of the general approach. So here is kind of like a little bit more way of looking at it. So you can kind of think of these as terms as well in a sequence, right? So our first term, we have one triangle. Okay, our second term, we have two triangles. And our third term, okay, there's obviously three triangles. Okay, so this number here tells us how many triangles are in the pattern. Okay, so our fifth term, if you will, is going to have 5 triangles, and you can kind of formally say, depending on what term of this particular pattern is, you'll have this many triangles, and you need to kind of alternate by flipping them upside down. So you can get more specific on how to describe this. So someone could just say, okay, write the 30th term of this pattern. Okay, so you wouldn't have to write out everything, but you just kind of give a general rule. All right. Okay, so hopefully that makes sense, and of course you will do more. This will make much more sense as we do some of the prompts and the example sets. Okay, now let's take a look at finding a number pattern. Okay, this is a little bit different than an arithmetic sequence or a geometric sequence, there's all types of sequences that we could be looking at. So one thing I would encourage you, just maybe pause the video. Try not to look at everything down here for a second. I know it's on the screen, but try not to look at it. If you want to look at it, that's fine. But see if you could figure out what's going on between these terms in this particular sequence. Like, what's the rule? Okay, how do we get from here to here? How did we get from here to here and here to here? Okay, so what is the one rule that will get you from these particular terms? Okay, so this is, I want to think of it as kind of like a puzzle or something along those lines, like a game. That's a good way to look at it, because that's kind of like what you have to do. You have to be kind of an investigator. So you kind of look at a pattern, and you got to really kind of like be creative or use your imagination and try different things. So let's take a look, right? So if I just look at these first two terms of this numeric pattern, I'm saying, okay, look, from 16 to 6, clearly I subtracted 10. Okay, so that works. Okay, however, here's the problem. If I go from 6 and I subtract 10, I get a different number. Okay, I get 6 minus 10. Okay, for those of you who know your positive negative number is negative 4. Right, so unfortunately this is not a negative 4, so that rule does not work. Okay, so subtracting negative 10 or subtracting 10, from the previous term is not the rule that works in this particular sequence. Okay, so you got to throw that out. You're like, oh boy, okay, that's not good. So what you have to do is you got to study the terms. Okay, now you don't have to start with the first two terms. You might want to just go to other terms, but you want to study terms that are next to one another. Okay, so like these two terms are next to one another, so let's see if we can kind of figure something out for these two terms, and then maybe we'll go back and test it for these other ones and see if it works. So if you look, this one's a little bit more difficult. It looks like, okay, to get from here to here, let's see, they both have 3, and this went up by 2. So maybe what we do is we add 2 to this top number, the numerator, and then we divide it by 3. Okay, so let's test that. Okay, so that's how we went from here to here. So let's test that on these other terms and see if that works. Okay, so this is the rule. So let's see here. From 6, if I follow that path or follow this rule, would it work? Can I go from 6 and will it land me on 8/3 if I follow this rule? So let's take 6. Okay, now 6 is also 6 over 1, so we're kind of talking about the numerator here, right? So I'm going to take that 6, I'm going to add 2, right, just like I did here, and then I'll divide that by 3. So what is that? Well, 6 plus 2 is 8, and 8 divided by 3 is 8/3. So, oh, pretty cool, right? So it worked. Okay, but let's really make sure that this thing is the correct rule for this sequence. So let's try from 16 to 6. We just tested from 6 to 8/3, that works. We know from 8/3 to 10/3, that works. Now let's make sure from 16 to 6 it works. So here again, what I'm going to do is I'm going to add 2 to the numerator, which is 16, and then I'll divide that by 3. Of course, 16 plus 2 is 18 divided by 3, which is 6, so it works. So there you go, right? So we want to go ahead and just kind of formally describe the pattern. So what's going on in this sequence is we take the numerator, we add 2, and then we divide it by 3, and that's how we get to all successive terms in the sequence. So oftentimes you'll be given a numeric pattern, which is some sort of sequence, and you got to figure out what the rule is. And you're going to have to be creative, and you're going to have to test a few things and double check. But you can do it. It's just not going to be as obvious as let's say an arithmetic or geometric sequence. Okay, so that's going to wrap it up. So in review, sequences are a list of numbers or objects that have some sort of special pattern, right? That's the main idea. In an arithmetic sequence, terms are separated by the same number that is added or subtracted. That's called the common difference. and a geometric sequence. Same idea, but the same number is going to be called the common ratio. And then lastly, finding and describing a pattern can be easy, kind of like with the triangles, or difficult, a little more challenging, as we looked at with numeric patterns or more, sequences that are not arithmetic or geometric. Okay, but the key is to really be looking for what is repeating and changing and making sure it works for all cases. So it just goes without saying that you definitely need to practice these concepts and really to make sure you kind of understand them. And beyond that, as you continue to learn mathematics, I promise you're going to study a lot more about sequences, and it's kind of a related topic called series. Okay, so with that being said, keep working hard, and we'll see you soon.